So last day I said this notion of what we called a free body diagram, Emily, is very important. I'm going to warn you, fair warning, the level of abstraction and difficulty, Nick, is going to jump dramatically. I don't know of a way not to do that. But if I continue to pound this at you and you wrap your brain around it, you've got a very valuable tool. It's no longer, well, what's the right equation? You're going to derive it yourself. What did we say? Let's quickly review. We said that a free body diagram was where we represented the mass of whatever object we were looking at with a dot. And then we used arrows to show any other forces, Christy, that were on the diagram. Found where we are? Good. Okay. We used arrows, and I said the arrows, Hannah, are roughly to scale. What I meant by that is if you know one force is bigger than another force, draw the arrow longer than the other force. Let me hit pause on my recording. So we said that we're going to show the rough magnitude of the forces by arrows. Brian, if I know two forces of the same size, I'll eyeball it, but Tristan, I'll try and make the arrows the same size. We're going to figure out missing forces that must be there using Newton's laws. And then we're going to use what I call the tug-of-war analogy. We're going to say which force is winning, which arrow is longer, which way is it accelerating. And we're going to go winner minus loser equals F net, where F net was always MA. By bringing that into bear, believe it or not, you can even handle stuff. Heck, if you take Physics 12, I'll even show you some university physics questions, and we'll still be able to, with a tiny bit of cleverness, figure out what's going on. We don't need much more than this. We looked at examples where we were finding tension in a rope. We introduced a couple of new forces to you. We introduced the force of gravity. We said gravity was mg, where g was the acceleration due to gravity, so 9.8. We didn't put the negative in this case anymore for the 9.8 because I've told you we're going to decide which way is positive based on which way makes the math nicer, so we don't need to put the negative in for the 9.8. We left off, I think, here in example 10. So it says this. Mr. Dewick, 92 kilograms, jump out of an airplane. Eventually I jumped out of an airplane. Once he pulls his parachute, air drag has a force of 745 newtons. What's his net acceleration? Are you with me yet or not?
Yeah.
Because you're fidgeting an awful lot. Can I have your full attention?
Yeah.
Thank you. Appreciate it. Cole, what's this question asked me to find?
The net acceleration.
Now, you might be tempted to say, well, won't I go VF minus VI over T? Do you see a VI or a VF or a, okay, or a VF squared or a VI squared or a D? Or no. What do you see? Do you see forces?
Yeah.
What are they asking you to find?
Net acceleration.
This is a job for a free body diagram. I'm going to represent me with a dot. I jump out of the airplane. Ah! What are the forces acting on me? Get the obvious one.
Gravity.
Yeah. What do I mean whenever I say the obvious one? I'm going to teach you, Matteo, to go systematically, because if you do that, you'll tumble onto more difficult forces that have to be there. Why do they have to be there? Because otherwise the physics just doesn't work. So systematically, get the obvious one. Gravity. Which way, Cole? Okay. What else? Read the question. Air drag. Which way? Up. Bigger, smaller, or the same size as mg? I'm not sure. You know what? Very quickly, calculate mg. Can you go 92 times 9.8 on your calculator? This is how I figured this out really quickly. Stop. Wait a minute. What nice round number is 9.8 really close to? What's 92 times 10? 920? Is 920 bigger than 745? Now, really, 92 times 9.8 would be a little smaller than 920. I think it's still going to be bigger than 745. So your trick of the day, Sierra, if you ever try to do a quick, rough calculation of what mg is roughly, just times 10, which all of you can do in your head, even Cole, and you'll be okay. So I'm pretty sure that air drag is smaller. I'll call it F air or F drag, whichever, just so I can tell the difference. So I drew the arrow smaller. Are there any other forces? I don't think so. So, look at your picture, Cole. Who's winning?
Bottom.
Okay. More specific.
Gravity.
More specific. Can you read to me 2 letters, please?
MG.
Thank you. Who's losing?
Drag.
F air? F drag? Not an M. I gotta be not a mass. So if I'm coming up with an equation, if I go winner minus loser, it's going to be winner minus loser. What does winner minus loser always equal? Hannah? MA. It's F net, but F net is MA. So now we're going to combine that into one step as well. Winner minus loser equals MA. By the way, this time we're letting down be positive. Why? Because it makes the math nicer. It does. What are we trying to find? How would I get the A by itself? Divide? Yep. Yet another equation. Don't memorize it. So you're telling me that I can divide by, in fact, A is going to be mg minus F air over M? Is that okay, Chloe? Cool, keep going. What's the M?
92.
Good. What's G?
9.8.
Yeah. Do I need to put the negative in? No. I actually, this time, it was much nicer to let down be positive. You get a prettier equation. Otherwise, you'd have negatives and all sorts of other crap kicking around that you have to deal with. Blech! Minus, what's F air?
745.
How do I know that's a force and that I can do that? What are the units next to the 745? Newtons. That's what force is measured. And so, yeah. Divided by, what's M?
92.
Here you go. Is this a fraction?
Yeah.
Is there more than one thing on the top? Brackets around the top. Is there more than one thing on the bottom? Okay. There's also a built-in error check. What's the maximum my acceleration could be if I was free falling in a vacuum with no error resistance? What's the biggest it could be as a magnitude? You all know this.
Negative 9.
As a magnitude.
9.8.
9.8. So I have to get an answer what? Smaller than 9.8. Do I not? So built-in error check, and I'm going to try and give you these along the way so that you can catch if you've made a dumb calculator mistake. Emma, if you get an answer bigger than 9.8, no, because in a vacuum, the fastest you can accelerate is 9.8. Yes, negative, but we're ignoring the negative in this unit. We're saying let down be let positive be whatever is most convenient. So please make sure you get an answer less than 9.8. I hope you do. On my calculator, bracket 92 times 9.8 minus 745. Close off the top, divided by 92. 1.7? And it's an acceleration, meters per second squared. So I'm still speeding up. Am I going to die? No. What's happening as I'm speeding up, air resistance is getting bigger as well. Eventually I'll stop speeding up. Does that mean I'm at rest? No, it means Newton's first has kicked in. The forces are balanced. I'm going to keep going at a steady speed. And Joel, that's what we mean by terminal velocity. Terminal velocity is when air resistance up and gravity down cancel each other out. And all a parachute does, Sierra, is make air resistance bigger so that it can cancel it out sooner so that the velocity is smaller. So my terminal velocity will be survivable. Good. Got a few more? Good. Caleb jumps from a 19.5 meter high cliff into a lake. Assuming his mass is 65 kilograms. Christy, what's A asking me to find? When it says how long? Time. You know what? Now we're going to go back to Unit 1 stuff. I'm not going to do a free body. I'm going to go T equals question mark. What else do I know? What else do I know here, folks? Oh, what's V initial? You do know V initial. Yeah, if you cliff jump, I'm pretty sure you don't throw yourself down to the ground. You step off. You might be going forwards, but vertically, your V initial is pretty close to 0. What's that 19.5, Sierra? But it's not 19.5. Yep. Right? What else do I know? I think you said it, Cole.
Acceleration.
What?
Acceleration.
Yeah. What? What is it?
Negative 9.8.
Good. So now we're back to before Christmas here. Can we find t from that? Yes. There is an equation. By the way, have I used the mass? Apparently I don't need the mass yet. There is an equation that has a t, a vi, a d, and an a in it. Which one? Sierra, which one? D equals VIT plus a half a. That one there? Oh. Why can I do that? Yeah, otherwise this is a, by the way, if VI doesn't cancel with the T, this is a quadratic and you need the quadratic formula. Have you guys done the quadratic formula now?
Yeah.
This is what I was getting at earlier this year when I was saying, yeah, if you've got a T and a T squared, you learn in math. If you have an X and an X squared, you're out of luck. Unless you bring in the quadratic formula. So now I could ask it, but there's some of you that might not have done it yet. Meanwhile, we don't need it here because we get this. D equals AT squared over 2. Where'd the over 2 come from, Christian? A half. Half times a half, divide by 2, same thing. Christy, what are we trying to find? How? What will I do with the A? What's the A doing to the T squared? Adding, subtracting, multiplying, or dividing? I'll divide it over. What will I do with the 2? The 2 is dividing, so I'll move it over. What's the opposite of dividing by 2? Yep, okay, it's coming back. I know we're brushing cobwebs off before Christmas. So if I hear you correctly, you're telling me this is also another equation. T equals 2 times D over A, but that's T squared. How to get rid of a squared? What's the opposite of squaring, folks? Square root. Now, some of you, it's possible, Maggie, that instead of having a 2 right there, you might have a 0.5 right there. If instead of writing it over 2, you kept the 0.5 there. It's the same equation, dividing by 0.5 and timesing by 2, same diff. I don't like having a decimal inside of a fraction. To me, it's bad math manners, so I tend to avoid that. I get this. T equals square root of 2, negative 19.5, all over negative 9.8. How do I type this into my calculator? 2 times negative 19.5 divided by negative 19.8, square root. You get almost exactly, but not quite, but really close to 2 seconds, 1.99? Yeah, it's all right, 1.99 seconds. By the way, that's a fair bit of time in free fall. So imagine you're stepping off the diving board now, 1,000, 2,000. You're falling, that would get your adrenaline rush up, I think. Cool. Emma, what's B want me to find? Which one, initial or final? Yep. I've listed everything up on the previous question, Emma, so if you don't mind, I'm just going to go VF equals question mark. And I'd like to see if I can find VF using those. I'll use time if I have. What? Wait. What month is it, Emma? Have we been doing physics for a while now? Since September? You know what? I'm going to take the most efficient route. And the most efficient route to find VF is that one there. Because it's already got the VF by itself. I know that means I'm using T that Christy found, but I think we're at the stage now where you're allowed to say, I'm pretty sure I did part A right, and I want to use it to find part B because it's less work. Okay. Is that okay, Tristan? What was VI, Emma? Oh, you know what? I'm going to go. So it's going to be negative 9.8 times 1.99. You know, it's going to be really close to negative 20 because it's really close to negative 10 times 2, but a little smaller. There's my built-in error check in case I make a mistake on my calculator. Negative 9.8 times, I wrote 1.99, but I'm going to use my answer button because it was still stored on my calculator, so why not? And what did you get? Negative 19.5? Negative 19.5? Why negative? Which way are we traveling when we hit the water?
Yeah.
Oh, okay. So that doesn't worry me. That doesn't surprise me. That comforts me. I did it right. Yes? Okay. All right. Suppose once Caleb hits the water, splash, his feet just barely touch the bottom of the lake. And let's say the lake has a depth of 2.5 meters. Not very deep. You wouldn't really want to be cliff jumping in a lake that was this deep. But, you know, this is Caleb. He's kind of a meathead, right? I didn't say which one. I'll let you assume that you know which one. Hannah, what does C want me to find? When? This is a new situation. I'm going to relist my data. I'm not going to go look at what I wrote for part A. So I'm going to say to myself, self, A equals question mark. Hannah, what else do I know? What else do I know? What's that 2.5? Okay. Mr. Doak, is that distance negative or positive? I'm not sure yet. I'm going to leave it positive, and if I get weird stuff happening, because I am still traveling down, it is technically below me. If I get weird stuff on my calculator, that'll be one of the first things I'll go look for if I get an error. What else do I know? What's VI? VI, once I hit the water, is Emma's VF at the bottom of the jump. So VI is going to be negative 19.5. That's two things to find the third. It's always, I need three things to find the fourth for this unit. What else do I know? What's VF? Oh, we're assuming that his toe ding, just touches the bottom, and that's exactly when he comes to a stop. You okay with that, Emma? Hannah, you okay with that? Looking for an equation. It's got an A, a D, a VI, and a VF in it. There is one. Can you get the A by itself for me? Because I'm lazy. I'll give you a hint. A equals. Nice. So it's going to be 0 squared minus, and then negative 19.5 squared in brackets all over 2 times 2.5. When we hit the water, Hannah, what direction are we traveling once we're in the water? Still, are we speeding up or slowing down? Which way are we accelerating then? Yep. Now, there's two ways to think about that. Hannah, if I let down be negative and I'm accelerating up, then my acceleration will be up positive, and I'll get a positive answer. Or, I could also say, once I hit the water, am I speeding up or slowing down? And we've also called slowing down a negative acceleration. This is kind of a weird situation because we're slowing down negative in the upwards direction. Positive. That's why I said I wasn't quite sure whether to make this 2.5 positive or negative. You know what? I'll just interpret my answer at the very, very end here. So I'm going to get, Hannah, is this a fraction? More than one thing on the top, brackets. You got to be very careful, 0 squared minus how you type the negative 19.5 squared in. If you do this, you might get the wrong answer because your calculator will square the 19.5, but it won't know that you want that negative squared as well. You have to put it in brackets. It's going to be bracket negative 19.5, close bracket squared, close off the top. And only then can we go divided by, is there more than one thing on the bottom? 2 times 2.5. And I get negative 76.05. This negative is saying slowing down, accelerating up. Because in this little version here, we found it more convenient to let down be positive, I guess. Negative 76.1. Did I think to ask how many G's that is? No, I'm just curious. How do I figure out how many G's that is? Times by 9.8? You're telling me Caleb was pulling 750 G's? And you know what? If you can't remember, do it that way. Try it, and if the answer looks nonsensical, it wasn't times, it was divide by 9.8. I got to do that twice to get back to the one I want. Okay, 7.8 G's, that would hurt. You'd probably be okay, but you'd probably feel it in your ribs. We did watch a video of the world record cliff jump, and I told you it sure looked to me that he didn't get his elbows tucked in on impact. It sure looked to me like when he hit the water, he got his elbows ripped up and probably tore a lot of the cartilage in his rib cage. That was the one where he crawls out, and you can see he's not doing really well, and he tries doing a cheer, and it's obviously a really weak, yay me, cheer. Okay. D. What's D asking me? Yeah, turn the page. What's D asking me to find? Brian, what's D asking me to find? What force? There's a word in front of the loud and proud. What? When I use that phrase, that's code. If I say find the force of gravity, or find the force of tension, or find the force of air drag, or you're going to do a free body diagram, you're probably going to have to go winner minus loser. If I say, and let's all of us right now underline the phrase net force, what I'm telling you here, Brian, is I've already done the free body diagram. I've already done the winner minus loser. I've already done everything. All we need to do is realize that F net equals. Did they give me M from the previous page? They did? Did they give me A from the water on the previous page? I think it's the answer from part C. Isn't it? Okay. But I'm going to ditch the negative here because we're back in forces and I'm not too fussy with always having down. I'm typically interested in the magnitude. So what was the mass? 65, you said? What was the A? 76.1. I'm going to use my answer button. What was the net force? I got a negative. I'm going to ignore the negative. 4,900, and I'll go to 3 sig figs, 40 newtons. You okay with that? Let's do a little thinking here. What if this mass was bigger? Same acceleration, but what if this mass was bigger? Would that result in a bigger force or a smaller force? Bigger force? What if this mass was smaller? Same acceleration. Pardon me? This is why little kids can wipe out so much easier than us once we're grown up. They're dealing with the same acceleration, but because they have a way smaller mass, their bones and their bodies absorb a way smaller force. It doesn't hurt as much. Have you ever wondered why, especially when you see toddlers or 4 or 5-year-olds, they can wipe out in the grass and be tumbling around? And if I did that now at my age, I'd be, oh man, yeah. Same acceleration, smaller force because of MA. Pole's going, well, that's kind of Captain Obvious, but that's why. Example 12. Draw, what does FBD stand for? Free body diagram for a cyclist moving to the right at a constant speed while pedaling. Okay. I guess this is definitely a job for a free body diagram. There's the cyclist. What are the forces acting on the cyclist? Get the obvious one. And by the way, cyclist and bike, we'll treat that as one big thing. Okay. What are the forces acting on it? Get the obvious one. Gravity, you say? Down. Is this cyclist sinking into the ground like quicksand? Are they flying into the air like Superman? So are they accelerating vertically in either direction? That must mean that the forces are, I'm looking for a word that begins with letter B, balanced. So there has to be another arrow pointing up, same length as the one that you just drew. Eyeball it. What force is that? What's that from? It's the ground, yeah. Because if magically the ground vanished, suddenly he would be in free, or she would be in free fall again, and falling and accelerating. It's the ground. The bike pushes down on the ground. Newton's third kicks in. The ground pushes back on the bike. We're going to give that ground force a special name in a few days. But for now, we're just going to call it F ground. What else? Cole said wheels pushing the ground. You're right. I'm going to simplify it. I think pedaling. We'll call it F pedal. Which way? When you pedal? Well, when you pedal, what really happens is the tires push backwards against the ground, but you get a push forwards. So I'm going to say that eventually you get some kind of a force pushing you forwards. Otherwise, bikes wouldn't work. So here's the question for a candy. Why must this be wrong? Why is this impossible? Dylan. Oh, all of us right now, and Dylan, I'll get you your candy, underline the phrase constant speed. Based on Newton's first law, is that possible to be going at a constant speed? This is how, Sierra, you can figure out forces that must be there, even if the question didn't mention. This is why I said to you, a free body diagram is such a valuable tool. Dylan, what else must there be? An arrow pointing which way? How big? The same size as which arrow? What's that? Yeah, that's what it is. That's why, by the way, professional cyclists, what do? They tuck. Because they've maxed out their force pedal. But if I lower air resistance, gives me a bit more unbalanced force, maybe I'll accelerate. Good. Good. I owe you a candy, don't let me forget. Example 13. Draw a free body diagram for an inline skater who's dragging the toe of one skate in order to slow down and stop. What do they want me to draw? Free body diagram. Well, clearly this is a job for a free body diagram. I'm going to represent the skater with a dot. What are the forces acting on this skater? Get the obvious one. That's there. When won't gravity be there? If we ever go into outer space, which we'll do more in Physics 12. I think I might do a couple with you this year in the homework where we're in outer space, but 99% of the time this year, gravity. Is this skater sinking into the ground like quicksand? Are they flying to like Superman? This is the value of Newton's first law. Then it tells me, it insists there must be a force pointing up that's balancing out gravity. And we're going to say, yeah, that's the ground pushing back. It's also why it's tough to skate in mud or on water or anything that can't apply that force up. You're going to start to accelerate down and things are going to go weird. What else? Which way is this person accelerating if they're slowing down and coming to a stop? Which way must there be an arrow pointing then? It has to be there if we're accelerating that way. But we're traveling forwards. Yeah, we're accelerating backwards. What force is that? I think that's the toe dragging. So you know what? Since we've used F drag before, I'll call it, in a couple of days, we'll call that friction between the toe and the ground, because we're going to learn how to calculate friction. Does there need to be an arrow pointing forwards? Yeah? Oh, which arrow would be pointing forwards then? What force would that be? Did you say speed? Speed's not a force. Right? I'm sorry. Speed's measured in meters per second. I need something that's going to be in newtons. Friction? I think friction's slowing them down. Oh, inertia? Inertia's kilograms mass, not force. Ready? Brian, I'm going to pick on you for fun. And because I like you, but mostly for fun. Which way is this person's velocity? To the left or to the right? Imagine the skateboarders or this roller skater is going that way. Which way is their velocity? To the? Who cares? Velocity doesn't show up in forces. What shows up in forces is acceleration. Are they speeding up or slowing down? So which way are they accelerating? Is that diagram there possible to be accelerating to the left? You don't have a force forward. So this is going to be one that I'm really going to have to lovingly beat out of you, because you're going to be saying, but he's traveling forwards, he's moving forwards. Doesn't there need to be a force pointing forwards? I don't care about the velocity. I care about the acceleration. Is this person slowing down? That works. Is there not an unbalanced force to the left? Newton's first says that that'll slow you down if you're traveling to the right. Now, if you knew this person was traveling to the left, this is impossible because they would be speeding up, and that's not what this question says what's going on. But we've decided to have this person traveling to the right. Friction slowing it down. Drag is slowing it down. That's all you need. But have I convinced you there doesn't need to be an arrow pointing forward? Is that okay? That's a common mistake. Even my Physics 12s really struggle with this diagram in particular. Physics 12, for example, I'll give them a car coming to a stop. And they so want to have an arrow pointing forwards because the car is moving forwards. It's so big, Mr. Dewick. Something must be pushing it forwards. No. Newton's first says it wants to keep going forwards in a straight line at a steady speed. The only way you can change it is to apply an unbalanced force. And since you're slowing down, that unbalanced force better be pointing backwards. Got my rant okay, Oliver? It's your homework. I already had to sign number 1. Number 1 is tricky already. Okay? I've given you the direction. I would, for number 1, do a quick little free body diagram. Either, if there's room on here, I would probably do this on a separate piece of paper. Quick free body diagram. You'll generate a new equation. And then in this case, it's asking you to find tension. Number 2. When I say weight, what's weight a synonym for? Another word for? No. Weight is not measured in kilograms. Weight is measured in newtons. What did we say in the notes? And we're going to do a bigger rant on this. So, Brian, the fact that you made a mistake, I'm not going to freak out. I will in a couple of days. What did we say? Weight is another word for the force of... Weight is mg, not m. Mg, not m. That's why the answer to number 2 isn't 5, because that'd be a boring question. So number 2 is fair game. 3 is really, really, really tricky. It's algebraic. I'm going to give it to you to see who can figure it out and have that ah moment. 4 is good. 5 is good. 6 is good. 7 is good. 8 is good. 9 is also really tricky because it's got multiple steps. I'll happily go over some of these tomorrow in class before we start. Or you can hit me up during a flex.